Hello, welcome again. In this particular problem, we are going to find out the velocity of the point B as asked in the question. So this again, just let me go through the page number. It is from page number 233, problem number 5, which says that a bar BC slides at C in a collar as shown over here in the figure. The velocity of the collar being 4 meters per second. The other end B is pinned on a roller. This roller is rolling on the horizontal surface, and they want you to find out the angular velocity of the bar BC, angular velocity of the bar BC, and the angular velocity of the roller. So let us find out the angular velocities, and for that I'll just first of all write it down what is to be found out. So we are just finding out omega BC and omega O. Okay, so these are the two things that we need to find out. Now, before we begin, we just have to note one thing, that this problem is a problem based on we have a rolling object which is rolling. When they have not given any condition about slipping, we have to consider this as rolling without slipping. So this roller is rolling on this horizontal surface without slipping. This is also a collar. This collar may act just like a small slider to us. So by this saying this as a collar, they are just trying to say that the point C is having a velocity of 4 meters per second. Point C is nothing but the point on the link BC. So to get the omega of BC, as we know that we need to know the direction of velocities of any 2 points. Now how do we do that? I know the direction of the velocity of point C, but I don't know the direction of the velocity of point B, which are the two known points to me. So can I get the velocity direction for point B? Yes, it is pin joint. As they have told, it is pin joint to another roller which is rolling on a horizontal surface, and just now as I told you, it is rolling without slipping. So this point B will also have a velocity with respect to this roller along this given velocity point of this roller. So where is this ICR for this roller located if it is rolling without slipping? Exactly, it should be located at a point which is in contact with the horizontal surface or on the surface where it is rolling. So for me, this point A is also the ICR for this roller, which is having the center at O. So if I join A to B, if I join the points A to B and try to draw perpendicular from this particular line, if I try to draw a perpendicular, I will get the velocity VB. So now I know the velocity of two different points on the same link, which is B and C. So if I try to draw perpendiculars from both the velocities, the intersection of them will be giving me nothing but the ICR. So let me just quickly draw the velocity perpendiculars. So I'll just draw the velocity perpendiculars over here. This is for the velocity for the point C, and this one, if I extend it, I will get it located somewhere over here. So just it is at the bottommost point, so I can say this point is nothing but my I point, which is the ICR for the link BC. Now this C velocity I already know, so over here I can say that VC is equal to IC into omega BC, but I don't know what is IC. IC is not known. So for finding out IC, first I have to find out what is the angle. I need to find out. For finding out IC, let us say in this triangle CBI, if I knew this angle, and if I knew this particular angle, I could have easily found out the value of IC. And do I know that? No, I actually know only this angle, because this is given over here as 30. This definitely becomes 60, but I don't know what is this angle. So to find out this angle, we may take help from something else. So let us just find out where we may be getting the help from. If I try to draw a vertical from this point O, this is 1 meter, this also should be 1 meter. Why? Because this is the radius. And if this is 45, this is 90, this total is 90, this total becomes 135. So the left out two angles, the sum of them will be, let me call this as theta over here. This also will be theta, because this side and this side, they are same, so they become an isosceles triangle. And in this isosceles triangle, these two thetas will be same. So 180 minus 135 will be equal to 2 theta. I just write it down over here. 180 minus 135 is equal to 2 theta. And this is in the triangle ABO. So I can just write it over here as theta will be equal to 22.5 degrees. Is it not? So this angle theta is exactly the same angle over here as well. So now I know this angle also, and this is 60. So let me just write it over here as 22.5. And this angle also can be now found out. This angle, let me call it as theta, let us say theta 1. So theta 1 will be nothing but 180 minus 60 minus 22.5. This will give me the angle 97.5 degrees. Okay, so let us move further now. Now from here we will be able to find out this length. So in triangle BCI, using sine rule, 4 upon sine of 22.5 will be equal to Ci upon sine of 97.5 will be equal to Bi upon sine of 22.5. Okay, so sorry, Bi upon sine of 60. This is Bi upon sine of 60. So just substituting these values, you will get Ci and Bi, which are equal to, Ci comes away somewhere around 10.36 and Bi comes somewhere around 9.05. This is all into meters. Okay, so now here we know these lengths, so I can just rewrite from my equation. Let me call this as 1. So from 1 I can find out VC. VC was actually given, so I can say that 4 is equal to 10.36 into omega BC. So omega BC can be known to me, which will be equal to 0.386 radians per second. Now the same omega, I can use it for VB. VB can also be found out as Bi into omega BC. So that can be written as 9.05 into 0.386. So this gives me VB is equal to 3.49 meters per second. So now VB is known to me. What I have to do is I want to find out the omega. First omega I have already known. So omega BC is known to me now. Omega BC is done. I want to find out omega O. So I can also write VB is equal to AB into omega O. How come? Because VB is also a point on this roller which has an ICR at A. We had just discussed that in the very beginning. So here if I find out AB, I can easily find out omega O. So how do we find out AB over here? Again, AB is very simple to be found out. AB can be found out just by using either cosine rule or maybe even your all the three angles are known. Now you can see ABO You already know this angle is 135, this angle is 22.5, this is 22.5. So use any of the equations, even using sine rule or cosine rule, you can find that out. I will not work more on that. I'll just simply find out AB and I'll give you the value. AB comes out to be somewhere around 1.645. So now based on that, 1.645 is your AB. So you can find out omega 0, calculate it. Omega 0 comes somewhere around 2.12 radians per second. It comes somewhere around 2.12 radians per second. So this is all about this particular problem. Thank you.